Good evening all. Last class we were discussing about different types of insulators and we have to continue with the same topic. We have some more types of insulator to be discussed. Next is strain insulator. This is similar to suspension type insulators because it is used in an overhead transmission system, but its specifications and working are somewhat different. The voltage capacity of the strain insulator is 33 kV. When suspension string is used to sustain extraordinary tensile load of conductor, it is referred as string insulator. When there is a dead end or there is a sharp corner in a transmission line, the line has to sustain a great tensile load of conductor or strain. A strain insulator must have considerable mechanical strength as well as the necessary electrical insulating properties. Mostly in the transmission line, it is placed in the bent, otherwise arm place. This is the picture of strain insulator. This being placed horizontally rather than suspending. This is also a strain insulator having three bases. This is the comparison between strain and suspension type insulators. Stay insulator. For low voltage lines, the stays are to be insulated from ground at a height. The insulator used in the stay wire is called stay insulator and is usually of porcelain. This is the picture of stay insulator. In the stay wire, actually it is being provided. The stay insulators, also called egg insulators, are primarily used to prevent stay wires from getting energized from accidentally broken live wires. Hence, they function to provide insulation between stay clamps and transmission points. Next type of insulator is the shackle insulator. Shackle insulator is also known as a spool insulator and is usually used in low voltage distribution network. It can be used in both the horizontal as well as vertical positions. The use of such insulators has decreased recently after increasing the use of underground cable for distribution purpose. This is the diagram of a shackle or spool insulator. The conductor will be driven through this groove and this insulator is fixed to the post or the cross arm by means of this arrangement. This is another picture of shackle insulator. This is how it is being fixed to the pole. Then bolted on both sides. There is a D-shaped strip. Through this strip, it is being attached to the pole. So you can see how the conductor is driven through the shackle insulator. The D-type structure is used to fix the shackle insulator to the post. These are connected to the pole using bolt, otherwise cross arm. The conductor in the groove is fixed with a soft binding wire. Our next topic is regarding the insulator is string efficiency. Suspension type string insulator consists of a number of porcelain discs connected in series through metallic links. Suspension insulators or string insulators are very widely used in electrical overhead transmission system. When the voltage is applied across the suspension insulator string, it is unequally distributed across the individual unit. The disc near the line conductor is extremely stressed. The voltage distribution on insulator string determines the flashover voltage and the voltage at which the localized corona and radio interference is being produced. Here we can see the tower, cross arm and the suspension insulators. Here we can see 3 discs provided on the insulator, and the conductor will be provided on the bottom portion. One end of the string is attached to the cross arm and the other end is attached to the conductor. The insulator material between two metallic pins form a capacitor of capacitance C called self-capacitance. Also, the air between each pin and the tower form the other set of capacitors. These capacitances are called capacitances to earth. This is how the insulators are being placed and the equivalent capacitances you can see. Self-capacitance as well as mutual or shunt capacitance. C1 is the shunt capacitance, C is the self-capacitance. Also the voltage distribution is also shown. C is the self-capacitance of each disc. C1 is the shunt capacitance between the metal link of string insulator and tower. V1 is the voltage across the first disc nearest to the cross arm. V2 voltage across the second disc. V3 voltage across the third disc nearest to the line conductor. V the voltage between conductor and the tower. Okay. Now we have to derive the expression for string efficiency that we shall see in the next session. So thank you.